This problem says two small identical conducting spheres repel each other with a force of 0.05 newtons when they are 0.25 meters apart. After a conducting wire is connected between the spheres and then removed, they repel each other with a force of 0.6 newtons. So when you connect the two conducting spheres with the conducting wire, what they do is the charges redistribute and become equal on them. So they repel each other with a force of 0.06 newtons. What is the original charge on the spheres? So let's say here's the Q1 and Q2 are the original charges, and the distance between them is 0.25 meters, and the original force is we'll call it initial force is 0.05 newtons, and then you had connected them with a conducting wire, and now the charge on each one of them is half the sum. The charge is equal because if you add these two charges, you get Q1 plus Q2, which is this original sum. And now the final force is 0.06 newtons. Okay. So the way this problem will be solved is let's write down what is it that they're asking. They're asking us to find Q1 and Q2. So we have two unknowns and we need two equations. So we'll have an equation for this force, we'll have an equation for this force, and that's how we'll solve the problem. Okay, so the initial force is K, the Coulomb's constant, times Q1, Q2 divided by R squared, and the final force is KE. Now each of the charges is Q1 plus Q2 divided by 2. Q1 plus Q2 divided by 2 divided by R squared. So let's put in some numbers. So the initial force was 0.05 newtons, and KE was 9 times 10 to the 9, and I'm not putting in units just so it doesn't clutter. 0.25 squared. So this equation tells us Q1 times Q2 is 0.05 into 0.25 squared. Into 0.25 squared divided by 9. Okay, so this tells us it's 3.47 into 10 minus 13 Coulomb squared. So that's the product of the charges. And let's see what does the second equation tell us. So we'll call this equation 1, we'll call this equation 2. The second equation tells us, okay, let's add a page. So the final force is Q1 plus Q2 squared 4, and that the 4 comes from Q1 plus Q2's divided by 2 squares, divided by R squared. So this is Q1 plus Q2 is equal to 4 r squared f final divided by k e to the power half. Okay, so let's evaluate that. 4 times 0.25 squared. The final force was 06 newtons divided by 9 times 10 to the 9. And they're all in SI units. Remember, I haven't put in units just to not deal with the clutter. So let's evaluate this. This is equal to 4 times 0.25 squared into 0.06 divided by 9. And this to the power. So this is 1.67 into 10 minus 12. So this is 1.29 into 10 minus 6 coulomb. So Q1 plus Q2, Q1 plus Q2 is that. Okay, so now we have two equations. Q1 times Q2 is equal to that. Okay, so let's write that down here. So Q1 plus Q2 is equal to 1.29 into 10 minus 6 coulombs, and Q1 times Q2 is 3.47 into 10 minus 13 coulomb squared. And so between these two equations we should be able to solve for Q1 and Q2. Okay, so what we'll do is from here we'll solve for Q2 and put it in here. Okay, so Q2 is 1.29 into 10 minus 6 minus Q1. And so Q1 times 1.29 into 10 minus 6 minus Q1 is equal to 3.47 into 10 minus 13. And so this is minus Q1 squared plus 1.29 into 10 minus 6 Q1 is equal to 3.47 into 10 minus 13. Okay, so that's the quadratic equation we got to solve for. Okay, so let me rearrange the quadratic equation. So Q1 squared minus 1.29 into 10 minus 6 Q1 plus 3.47 into 10 minus 13 is equal to 0.